Hi guys, this is just a quick debrief video going over the random assignment activity that we started last week. So in this video, I'm just talking about what happened. So remember last time we had this land plot situation, right? We had the trees and the stream on the left and the trees on top. Your job was to randomly assign A's and B's. The A's represented land plots where kalo was planted under the moon phase kupao, and the other B's represented some other moon phase. So answering the questions we skipped last time, what is the experimental unit? Experimental units would be the thing that the treatments are applied to. And if you think about the treatment is the different moon phases, right? So the treatment would be the Kupal moon phase. That means the experimental unit would be the land plots, the different land plots. Okay, so number two, why do you think it's important to randomly assign the moon phase to the plots? Would it have been a good idea to use moon phase A on the eight plots on the left of the diagram? And looking at our diagram, that would not be a good idea because you got the stream and you got the trees, right? So it's very possible that this is better land because it's closer to water, or maybe worse if there's too much water or something. But either way, it's possible that this affects the outcome. So it's not a good idea to only put one type to the left or in the top either, right? Because you have the trees on the top and you don't have anything in the bottom. So what makes more sense is to randomly assign. That way you're more fair to the A's and the B's, to the different types of moon phases. Okay, this was your task last time. Create the Padlet posts, and I actually have three different sections of Math 115 this semester. So what I did is I tallied up all the results from all the different Padlet posts that you guys made, and I made a spreadsheet of it. So I forgot to open that up. Find it. Here we go. Okay, so here I have in the spreadsheets all the values of A's to the left of center, right of center. You notice each one adds up to eight, right? For eight A's. And then, oops, I had here, we're spring 2025. Yeah, here we go. So the bottom is the total. So total left was 293, total right is 307, total above was 289, and total below was 311. So let's go on to our debrief questions. I inputted those numbers already. And then question number three, did your random assignment result in an approximately even split left and right of the vertical line? And what about above and below? And looking at our numbers, yeah, amazingly, 293 to 307, that's really pretty close. I mean, maybe you think it looks kind of far because that's a difference of what, 7 plus 7, 14. But think about it in terms of how many land plots that is. So 293 plus 307 is 600. So out of 600, we have only a difference of 14. And look about this one, also 600, right? This one is a little further apart. So 89, that's 11 to 311, that's 22. 22 apart. But out of 600, that's a very small percentage. So in fact, let's just do that calculation. What is it? 22, I said, divided by 600. That's about 3.67%, right? This one was 14 out of 600, which is just above 2%. So that difference is relatively small in comparison to how many land plots we're talking about, right? Okay, so we answered question three. Number four, in experiments, random assignment is used as a way of ensuring that the groups that receive each treatment are as much alike as possible with respect to other factors. In this case, the factor would be the trees or the stream, right? The location close to that. Explain what this means in the context of this experiment. Well, I just basically told you what it says, what it means. But you know what I do want you to note though here, guys, is that when we selected our land plot positions, we weren't even looking at where the trees were. We did it blindly, right? We did it totally randomly. And so we weren't even taking into account like at face value. I guess we could have done like a block design, so we specify that okay, we must have like four on the left and four on the top, but we didn't do that. We just totally randomly assigned them. And what ended up happening is by randomly assigning things, we actually ended up with a roughly even split anyway. So the power of that is that we accounted for the confounding variable of the stream and the trees without even really straight on addressing them. That means if there's some other confounding variable that we're not aware of, by randomly assigning the land plots, we are actually accounting for that as well. So that's kind of the power of randomly assigning um, things to the treatment group or the non-treatment group. is that you're accounting for these confounding variables that you're maybe not even aware of. Okay, coming back to the last question. Number five, suppose at the end of the experiment, the mean yield for one of the moon phases is quite a bit higher than the mean yield for the other moon phase. Explain why it would be reasonable to say that the moon phase is the cause of the difference in yield and not proximity to the river. So that's easy to say because roughly you have the same amount that are to the left, right? So you got roughly the same amount of A's and B's that are close to the river, which means it's not really an unfair advantage because they're about the same. The same thing for the top or bottom. Okay, so that's it, guys. Your discussion job this week is to just respond to the response questions that are posted about this activity. So see you in the discussions.